It seems that after the first year, there is an abrupt change in human development, certainly in motor and cognitive terms, but also in the social domain. Babies are highly social, but their interactions are mostly one-sided. Crying or smiling are strong signals for the caregivers, telling them that the baby needs to be fed, cleaned, or otherwise comforted. However, after the first year, or thereabouts, their interactions become truly reciprocal. This is evidenced because children start to display joint attention, also known as shared attention. Joint attention is where two individuals are deliberately and simultaneously attending to an object. It involves the ability to coordinate one's own attention between an object and another person, to indicate a need or simply to share interest. For instance, here Danny first looks at a toy that he thinks is pretty cool, then he looks at his mother, and then back at the toy, suggesting that he is directing his mother's gaze towards the toy, and that he is aware that the mother is looking at the toy as a result. A child can direct someone's attention with eye gaze or by pointing or with words. This relation is no longer a dyadic one between a perceiver and an object, but rather a triadic relation involving two joint perceivers and an object of perception. This is thought by some to be the basis of truly reciprocal interaction. Lack of joint attention is indeed a worrying sign of autism. Baron-Cohen gives the name SAM to the cognitive mechanism that enables this important change in the way the child interacts with the social environment. SAM is an acronym for Shared Attention Mechanism. It receives inputs from the basic mechanism we've already reviewed. SAM's main function is to identify whether you and another person are attending to the same thing. And, as we suggested earlier, this requires triadic representations. The more primitive components of the system deal in dyadic representations, which always relate two things: a self and an object, or an agent and an object, and so on. However, in a triadic representation, one can relate two perceivers, namely the self and another agent, with an object being jointly perceived. For instance, an example of a triadic representation may be, I see mommy sees the bus. Here you have three participants: self, mommy, and the bus. Notice that the first occurrence of the seeing relation, relation 1 in the slide, encompasses the whole event of mommy seeing the bus, which is itself encoded by a dyadic representation that centers around relation 2. But perhaps a non-linguistic representation makes clear what the triadic representation is symbolizing. Here you have the dyadic event of mommy looking at the bus. And on top of that, self is not only looking at mommy and also looking at the bus, but it is also witnessing the whole event of mommy looking at the bus. Once self is encoded as a participant, this establishes a triadic relation that builds on the already existing dyadic relation between mommy and the bus. Consequently, and in more formal terms, SAM builds triadic representations by embedding dyadic representations into larger ones. It does so by means of a recursive process that is reminiscent of Russian dolls being put into Russian dolls being put into Russian dolls, and so on. We've seen processes like this in other areas of cognition, especially in the way human languages build phrases. So, for example, Sam would receive from Ed the dyadic representation mommy sees the bus, and then it would embed it into a larger frame to generate the triadic representation I see mommy sees the bus. Similarly, it can take the dyadic representation I see daddy and then produce the representation mommy sees I see daddy. In short, the functional role of SAM is the following. As input, it takes information about what self and other agents are perceiving, or what their goals are, and then it outputs triadic representations specifying shared or joint attention. Schematically, it takes as input dyadic representations of the form X sees an object Y, and Z sees some event, and it outputs representations of the form Z sees that X sees something. As we said, Ed uses mostly, but not exclusively, visual representations. It tends to rely heavily on Ed because joint attention is most usually inferred from visual cues. However, Sam can in principle build triadic representations via any modality. Also, Sam can work with its outputs. It can take a dyadic representation like self wants toy and embed it to form the triadic representation mom sees that self wants toy. Moreover, notice that there is also some backtalk, so Sam is not merely a feed-forward mechanism, so to speak. For example, Sam can make its output available to Ed, so as to allow Ed to read I direction in terms of goals and desires. As a result, when Ed is linked up to id via Sam, I direction can be interpreted in terms of mental states like desire, goal, and reference. This will eventually endow the child with a whole new ability that will be exploited by the fully fledged theory of mind. This is the ability to infer a broad range of mental states from looking at face expressions, and especially the eyes. For example, when shown this pair of pictures, typical people have no problem detecting which of them expresses happiness and which of them expresses fear, or which one in this pair expresses distress, or which one shows a rather pitiful attempt at flirting. So let's review the main features of Sam by means of a comparison with the early components of the system. First of all, Sam emerges later than the previous three, since it usually appears between the 9th and 14th months. In terms of its inputs, it is amodal and form-independent, just like Ted and id, and unlike Ed. Its outputs are built out of the primitives employed by the early systems, so it can produce representations that encode volitional, perceptual, and affective states. Thus, the outputs of id, Ed, and Ted are recursively embedded in perceptual representations that express shared attention. And these representations of joint attention events are triadic in that they involve three participants. So, although Sam constitutes an enormous advance with respect to the previous systems, it is still limited. It can only work with a fairly limited inventory of representations of mental states, such as wanting, seeing, and being happy. But our adult mind-reading capacity involves a rich array of complex states that go way beyond this basic set. Think about attributions of suspicion, hypocrisy, or nostalgia, just to name three. Also, Sam can tell us how all these states interact in a systematic way to generate typical patterns of thinking and action, so as to allow us to predict people's actions from our knowledge of their beliefs, desires, and intentions. These sophisticated capacities require the contribution of another system.